Okay, so this is sort of the first thing you see in Onshape, the tutorials and samples where you can go through everyone and see how things work. You also can create your own new Onshape documents up here. As you see here, I have one of 10 private documents, 3 megabytes of 100 megabyte private storage, and 3 megabytes of 500 gigabytes total storage. That's because I have a free subscription, so then I am limited to only 10 private documents and 100 megabytes of private storage. If I want to do anything else than that, I have to make the projects and documents public so that everyone can see them. Which is not a problem really when I'm doing this for my blog, because I want people to see it anyway, so I'll be using public stuff. Also, you have down in this corner, you have an app store where you can actually link different apps to Onshape. So we can just have a look at this one before we start up. We have to sign in and stuff, and then you get things like a PDF exporter, different kinds of rendering tools. You can get solid parts and trace parts integrated so that you can download finished parts directly from them, like isometric screws, bolts, and stuff like that. You can get bill of material lists hooked up to Google Sheets. You can get 3D printing stuff mixed in with it. You can actually have finite element apps connected to it. CFD simulation apps, you can get that one too. Even time cards to track your hours of work if you're doing this to earn money. You can even integrate Swift calcs, which I use for my calculations, and lots of other stuff. So I'm pretty sure that they're going to add even more apps that you can integrate later on. So we're going to create a new one here. Create a new Onshape document. We're going to make it public, and this one will be called wall mount. Create a public document. There we have it. And I've noticed that in several other Chrome extensions that I'm using and web pages and stuff, that the current Chrome version 49 is apparently, it has some sort of difficulties with it. There's a lot of extensions and stuff that have problems with this 49 edition. Late March, a new 50 edition will come out of Chrome, and then probably will be fixed. And now, like, Swift calcs is actually significantly slower calculating in Chrome than in, for example, Firefox. So it's probably the reason why we have some loading time here on Onshape too, although I haven't read anything specific about that. So you can see we have gotten this one up. We have a front plane, a right plane, a top plane, and we have a center. We can maneuver using this cube, more like what you do in Inventor. Just click the sides of the cube and it will rotate and everything. You can also click and drag on it to move it to another space if it's in your way. There we have all of the 3D features you can use for it. We have the feature tree here on this side, and also you have the sketch mode, which will be how we start now. So we'll do sketch. Let's just do the front plane. This. So now our sketch is on the front plane, and we can sort of move it. If I can remember how to do this, I've only made a couple of stuffs in here, so we can do view normal to sketch plane. That was how we did it. So then we do a rectangle here. We'll just put it out basically like this. So now we'll need to remember what the measurements were supposed to be. So we'll look at my beautiful hand-drawn drawing here. So we'll start with this piece in the bottom here. So it's supposed to be 30 wide and 30 deep. So we get, oops, that's the dimensions here, which is sort of fair enough, because then I can show the dimensioning function here. So just put this one out. It's supposed to be 30 millimeters that way. And then we do 30 millimeters this way too. Maybe we would like to center it on in the sketch here. That would be nice to be able to do that. So we have a horizontal constraint. So it must involve something from the sketch, it says. Let's see if we can get it to work. Oh, it does not have the same function as in Inventor, where you sort of do the midpoint of the line. But then we can do it quite simply by just putting in the measurements. This one has to be 15. Put it in the correct place. I'll just have to move the entire triangle over here. So I'll do another 15 placement here. Didn't work. 15 there. So we've centered this base part. One thing that is a bit nice with Onshape, as I've seen, is that you can basically just make a lot of pieces in this sketch, and you can extrude them one by one. You don't have to extrude everything at once, so the sketch is easily shared between features, as apart from in Inventor, where you have to actively go into the sketch and choose that you want to share it. So here in Onshape it seems to be a bit better. So because of that, I am going to also put up the other part here, the part that is going straight up. So that one is 3 millimeters thick and 30 wide. I'm going to put it in at the top here. So we'll latch onto that one. We'll latch onto that one. 30 wide. That's set already. And we wanted it to be 3 millimeters tall. 3. Zoom in here a bit just to see everything a bit better. So now I'll close the sketch. So we're done with the sketch, and now we can start to extrude stuff. We have the extrude button here, so we'll extrude this region. Let's see it a bit better from the side here. So now it's going to extrude at 25 millimeters. That's a bit too much. Let's see here. We need 2.5 millimeters to get up there. Let's do all 5 millimeters, and then we'll cut away this piece here. So I'll do the full 5 millimeters of extrusion. And then we just do this one. Should be okay, yeah. So that's the first extrude. Let us do another extrude. We'll just mark the sketch again. We'll do another extrude on it. And now we'll do the top part. Let's just rotate ourselves a bit here. We don't want to do everything here. We want to do just this piece. We're going to add solid, and we're also going to do the sketch. Now it's sort of doing one or the other, so it doesn't want to do what it did for me before. I'll try Might be me doing stuff wrong here. So we'll do the sketch. I'll try to just do an extrude. Then we'll do entire sketch there, but I'm not doing. I'm supposed to clear selections there. That's a bit better. So now we are just going to show the sketch. We're not going to mark the entire sketch. That was what I was doing wrong. I had the entire sketch marked. So now we're going up here. Let's see. We need 30 of total height. So we'll do 30 millimeters up here. Now we have 30 millimeters. And now we want to do another sketch. We'll do a sketch on this surface here. That surface. And we want to do normal to the plane. So now we're going to make the cuts here. Cuts in here. So we have basically 2.5 millimeters in height, 2.5 millimeters in width in here, and then 5 millimeters in there. So we'll do lines for this one. We'll start in the corner here. We'll do 2.5 millimeters there, or not. 2. And then we're supposed to go somewhere down here, and then over here again. So now it's snapped to a perpendicular snap there. So what we want to do now, what I could do is just put a 45-degree angle on this one, or I can set the dimension of the lower one here to 5 millimeters. This one, and we want it to be 2.5. Let's try to do something I haven't done before. I'm going to try to mirror this one, if we can find this function. So let's see here, that's a linear pattern, and there we have a mirror. So I'll try. We have to select a mirror line, so I'll select this one. And now we have to select entities to be mirrored. So this one, this one, this one. Yeah. So that worked even better than it does in Inventor, actually, because it just did line by line and you can see them instantly. In Inventor, you don't get to see them before you push the apply button. So now I will have to just close these off to be sure that it's going to cut. And close this one off to make sure it's going to cut. Then we're done with this one. So we have a new sketch here. Let's tilt it a bit so we can view it better here. I think I'm actually going to remove these planes now. They're a bit hide all planes. They're a bit in the way when we're drawing here. So let's do extrusions. Choosing this one and this one, but we're going to remove instead. So it's cutting in here. It's not going all the way in. So we're going to have to add a bit here, because we had 30 in the bottom line here, and then only 3 here. So we need 27 to get all the way to the edge. That works. Yeah, 7. We got all the way to the edge there. So we'll let this one stay there. And now we'll make the part that goes out from the top here, this section. So we need about 6 millimeters plus 1.5 millimeters. So let's say 7.5 exactly then. So we'll put in a new sketch in this face, and we'll view normal to sketch. We'll just flip it a bit to get it on the top side here. And we'll put fasten it to the top there, a bit down here, and we'll see what we have there. In my original sketch here, I've done 3 millimeters down there. This means that I only exactly make these teeth enter. But what I'm going to do now is that I'm going to increase this one to 4 millimeters, because then we're putting a bit of strain on all of this. When I screw the screws into the wall, then everything here is going to be a bit under strain. It will keep the switch into place better. So we're going to do 4 millimeters down here. 4 millimeters. And this one. Now we do the extrude. Here we're going to just tilt it a bit so we see it. And 7.5. Here. 7.5. Now we need to do the teeth for this one. And the teeth, as I mentioned in my previous blog post, are not exactly set yet. As you can see here, I don't have any symmetry or anything. They're just placed randomly, more or less, according to measurements. So what I think I'm going to do, the outermost, the two outermost teeth, and I'm going to put them a little bit inside the edge. So we have 8 millimeters plus 12 millimeters. So we're up to 20 millimeters plus 0.9 millimeters between these. So we have 20.9 between them. Let's just tilt this one a bit and we'll make a new sketch underneath here. Right there. And we're just going to go normal to the sketch plane just to make it a bit easier to see. So what I'm going to do is I'm going to put out one piece here and one piece here. And what I already know is that I have a distance of 20.9 millimeters between them, and a total distance here of 1.4 millimeters, actually 4 millimeters on this one, 4 millimeters there, and 4 millimeters there. So we have 1.5 in depth. Then we'll see if they have a collinear thing here. They actually have something called midpoint here, so I could probably have done what I wanted to do earlier anyway. So tangent, parallel. Let's try two more entities. If it's like two or more lines, curves, we can try with this one. So we could constrain this one to this one, coinciding. Yeah, they both have the same depth now, 1.5 millimeters. So that works. So now we'll put out a midpoint on this one, a midpoint, if that works. No, that was probably constraining it to the midpoint. That one does. So we'll see here, we can move everything a bit further over here. So we don't really have a lot of room on the edges here. I'm going to zoom in a bit. We need to try to figure out a way that we can put this one up here, just like that. So 0.621. So what we actually could do is, if this has the same functionality, I've not tried this yet in Onshape, so I'll just see here if this works, if I can do this one. No, I cannot mark them as I can do in Inventor, but maybe I can do 20. 9. Oh, let's do 30 minus 20.9 minus 8, it should be 20 minus 8, and we'll divide by 2. If it works. Actually works. So you can do calculations in there. So 0.55 there now. And let's check the other side just to make sure. Should be 0.55 here too. 0.55 here too. Yeah. So then we have everything set for this one. We have 2 teeth to keep the switch in place. Let this one stay, and I'm going to extrude them 1.6 millimeters. So extrusion, this face, and this one. So here, it's a bit further than we had intended. 1.6. That looks better. So now we have the teeth in place. What we're going to do next is we're going to do the hole in the middle for the screw head. The hole here. We're going to save the lid for next time, and we're also next time we're going to do some more work on the wall mount itself. We're going to round some edges, make it a bit cleaner in the shape, and also we need to do something to keep this lid into place, not just pushing it in, but we need to have some sort of obstruction out here in the edge, which will sort of lock the lid into place. So we'll go up from this side. Maybe we could actually just do it from we'll do it from the back side here, actually. But we're going to need a plane to do it through, so I'm going to have to just tilt it a bit. So plane through the center. Which plane will that be? Let's see here. That will be the top plane. Yeah, that goes straight through the center. So we can do that one. And we'll do a sketch on the top plane. There, let's go normal to sketch plane. And I'll start drawing in here. So we'll need to start at the center. Remove. It was 4 millimeters in the bottom here. So we'll move 2 millimeters out from the center. No, I have to put it out first. 2 millimeters. And then we'll move some way up here. And then we'll move up here somewhere. I can't get it to fit on that one for some reason. Yeah, maybe we'll do it another way. I think it's because I'm doing a plane in the middle of the part here. So we're going to flip it the other way around. Go to the bottom here. I'm just going to do a hole instead. So we have a hole function here. We don't need a counter bore, but we're supposed to have a counter sink. So if we go from this side instead, we look at it from the top. We'll do a counter sink, where we don't need a blind one, we're going to go through it. We'll have a 90-degree counter sink, and the diameter will be 7.5 millimeters up here, and the diameter down here will be just 4 millimeters. So it wants to start from the sketch plane. So maybe I'll actually have to do a sketch anyway on top here. So let's do the sketch on top. Then I might just as well put a point in. So there we have a point. I'll put the point in here. The point is to be vertical compared to this one. I want to be vertical. And it's going to be along the midpoint of this one. See if this works. Sketch could not be solved, so it can move it down to midpoint. It won't manage that. So now it has the midpoint and now that's the vertical one. So we'll do a dimension instead. There to there. And we'll do 27 divided by 2. There. We're not exactly in the center, but we're in the center of this square here. Or this rectangle, not a square. So we'll put this one out. We'll do a hole function with the counter sink through. And we'll do a custom one. So 4 millimeters, 7.5 millimeters, and 90 degrees. I'll check what happens. We can't check what happens. We of course have to mark the hole the sketch is supposed to be. Looks right. It has a larger dimension up top than below. Gotta put it in there. And nothing happened. Let's see. It's red here, so it did not generate properly. No target parts selected for hole. Let's see. We'll just go with this one. Yeah, that's better. So it's just me not doing my job properly. So there. That should fit nice for the top of my screws. So that's it for today. We'll just leave off here and we'll continue hopefully next week. I'm kind of doubting that I have time then, but I'll try.